In this video, we will discuss the problem print anagrams together. Problem says that we'll be given an array of strings and we have to return all groups of strings that are anagram. So the group must be created in the order of the appearance of the elements here. We have to look at the sample test case for more clarification. So let's have a look at the sample test case here. If you will see, we have been given the test case, that is God, cat, dog, cat. So this particular array of strings has been given to us. Now how can we identify an anagram? So what is an anagram? If you see here, the string ACT and the string CAT, these two are anagrams. Why? Because you can see A is occurring one time, C is occurring one time, T is occurring one time in the string ACT, and in the second string cat also A is occurring only one time, C is occurring only one time, and T is occurring only one time. So in this case you can see that all the alphabets that are there from A to Z, they have the same frequency and their order of occurrence in the string might be different, but you can see overall the frequencies are same, corresponding frequencies are same. A is occurring one time, A is occurring one time, C is occurring one time, C is occurring one time, T is occurring one time, T is occurring one time. So this is what we call as an anagram, when two strings have the characters with the same frequency and the orders of the characters might be different. You can see A is occurring here in the starting, here A is occurring in the middle, but overall the frequency of all the characters are exactly the same here. So that is why they are anagrams. Now what will happen here? If you see which anagrams will be grouped together, so you can see here obviously that the string ACT and CAT and TAC, all these strings are anagrams. All these strings will be clubbed together because A is occurring one time in these strings, C is occurring one time, and T is also occurring one time. So we'll club ACT together, then after that we'll club CAT and TAC. So we'll club all these three together. Then after this you can observe, next up what will happen is you can say that the string God and Dog. So in God you can observe that G is occurring one time, O is occurring one time, and D is occurring one time. In dog also all the characters are occurring one time exactly, and there is no extra character. So that is why what will happen is God will come together and Dog will also come together. So these two will be clubbed together. So these are the two different groups that we have, and we have no third group. Correct. Now how can we solve this particular problem here? In order to solve this problem, we can use one approach, that is hashing approach. Now what we can do is we can easily identify one thing, that suppose whatever string has been given to us, if we try to sort it, okay, obviously I'll be maintaining the original string that has been given to me, original ith string that is there, I'll maintain it, but I'll also try to generate a sorted string. Okay, so for ACT the sorted string will be ACT only. So what I'll do is I will say that with respect to the sorted string, okay, with respect to the sorted string, I'll try to create a list of the strings here. Now what do I mean by this? You'll understand this when I'll do the dry run. See, initially I have got act. So inside the map with respect to act, what I'll do is I'll store act only, because act itself looks like sorted, and when I sort it also, then it is act only. Then after that, the next string that I go come across is God. So when I'll sort this string, what will be the sorted string? It will be DGO. So with respect to DGO, what I'm going to do is I'm going to store God inside the list here. Okay, because DGO is the key that I'm maintaining, the sorted string is the key that I'm maintaining, and with respect to it I'll store the corresponding string that I had originally. Okay, then after this I have got cat. Now the moment I get cat, if I'll sort this string, I'll get ACT. So with respect to ACT, I'll put cat inside this here. Then after that I have dog. Now if I have dog, if I'll sort it, it will be like DGO. So with respect to DGO, what I'm going to do is I'm going to put dog string here. Now after this, what will happen next time I'll be at this string tag. When I'll sort it, it will be basically ACT. So with respect to the ACT key, I'll put tag here. So I'll put tag in this list, in this map here. So you can see here that what happened was I kept my sorted string as a key. So you can see here that the sorted string is the key here, and with respect to it I'm putting the strings here. So you can see that whatever ith string I am at, I am first of all sorting it by creating a copy. I'm sorting it, and then with respect to the sorted key, I'm putting the ith string inside the list here. So this way you can identify that I have created two different lists which are anagrams. Okay, so you can see here that ACT, CAT and TAC, this is one list. So I've got one list that is ACT, then after that I've got CAT as well, and then after that I've got TAC. So I'll iterate in the map, and I'll first of all get this list, because this is the very first list that I have. I'll get this list, I'll print it, and then after that the second list is God and dog. So this is the second list that I have. So I'll get this list as well from the second key here. Okay, and I'll just return this. So this is how I can easily do it. The main idea is that if the characters are jumbled in anagrams, so when you sort them, so everything will be the same, both the keys will be same. If you consider two strings which are anagram of each other, then their sorted string would look like the same. That is why we are keeping the key as the sorted string here. Now if you see, what are we doing? Firstly, the thing is that we are sorting every string here. So the thing is that, assuming that if a string is of length k, so I'll take k log k time, because assuming that if one string is of length k, then I'll take k log k time to sort that string. And for how many strings I'm doing this? For one string, for one given string, I'm sorting it. So it will take k log k time. So I have how many strings? In general, I have n strings given in the array. So for n strings, I'll take n into k into log k time, which is quite high. The complexity for this particular problem using this approach is quite high, because obviously I'm sorting every string. So I'm taking k log k time. And then after that, like I'm doing it for all the n strings, so it will be n into k log k here. So yeah, let us have a look at the code and how we'll be implementing it. I'll do a dry run correspondingly as well. You can see here that initially we have a resultant list. Initially it is empty, so its length is basically equal to 0. Now after that, if you will observe here, so you can see here that we have a resultant list. Initially its size is basically equal to nothing but 0. Now you can see that like why are we creating this resultant list? Because it'll be storing two lists here. So resultant will be storing two lists. You can see one will be at the index 0. In it, you have at the index 0 you have got this list, and at the index 1 you will get this list. Okay, so this is something that we expect here. Now if you will see here, what will happen is, initially when we come across the string act here, so we will sort it and we'll get what? We'll get ACT only. Correct, we got ACT here. Now we'll check, is ACT present inside the map? No, it is not present inside the map. If it is not present inside the map, then what should I do? So in this case, if it is not present, then with respect to the string, let's say ACT, what we are going to do here is, with respect to the sorted string, we'll update it with the length of the result. Initially the result is not having anything, so the length of the result is 0. So this means that this string would belong to the 0th group here. Then after this, what we are going to do is, inside the result, we are going to create an empty list here. So what will happen is, now the resultant string, like the result will have the resultant list will create an empty list like this. Okay, the very first list like this. Now what happens here is, you can observe that after this is done, then with respect to MP of this string, whatever is the group number of the string, will add this ith string here. So what will happen is, this string is act. As of now, the sorted string is act. With respect to this, the group number is 0. So in the 0th list, we are going to add the corresponding string, that is ACT. So ACT will get added here like this. And after this, what will happen next? The next string that will come across is basically this string god here. Now when I come across this string god, so the actual sorted string will be DGO. Now if I have got DGO here, what should I do? Now the moment I have DGO, so it is a string which is not present in the map. So what I'll do is, I'll say that with respect to DGO, I'll update it with the result length, length of the result. Now the result length as of now is 1. It is containing one list. So now this will be updated to 1. So this means that the DGO string will be the second group that we are making, and it will be at the index 1 here. Now after this, what will happen is, with respect to this MP of DGO, whose value is 1, you will update it in the second list. So what you will do is, in this second list, you're going to update nothing but the string god here. Then after this, what will happen is, next time you will be at the string cat here. So you'll sort it, it will be like act. So now act is already there. Now act is in which group? 0th group. So with respect to this 0th group, add the string cat here. So cat will be added here. Then after this, what will happen next? You have the string dog. Now when you will sort it, it will be like dgo. Now dgo is already there. It has the grouping as 1. Its value is 1 here. Now since its value is 1 here, so you will put it in the first group. So dgo will be dog will be put here. The corresponding string, ith string, arr5 will be put here in this group. Okay, then after this, you have the next string, that is stack. When you will sort it, it'll be like ACT here. Now it is in the 0th group, so add it. So this will be tac here. So tac will be put directly like this here. Now you can see here that the resultant string is looking like this. The way that I had told it, it would have worked as well initially, but the drawback of that approach is that you have to do two iterations. Firstly, you have to store everything in the map. You have to store this thing in the map, but and after that you have to iterate, and you have to put this list and this list again. So that would take two iterations. But the way we have implemented it here, it will take only one one iteration. So this is the advantage of this approach. Basically, with respect to the sorted string, you are updating the group number depending on the result size. Okay, if the sorted string is not there in the map. Now once this is done, then you can simply return this resultant list here. Okay, the time complexity will be n into k log k, as I told, because for one string the sorting would take k log k time, and there are n strings, so it will be n into k log k. Then after this, the space complexity will be pretty high as well. The space complexity will be basically n into k. Why? Because if one string is of length k and there are n strings, so the storage capacity would be n into k here, because one string takes length k, so n strings will take the space as n into k here. Now can we do this problem more optimally? Yes, we can do this problem more optimally using the concept of frequency of the string as a key here. Now what do I mean by this? I'll explain this in simple terms here. What I'm trying to say here is that, let's say if I have been given this string act here, so you can assume that a is occurring how many times? One time. Then like you know that b is occurring 0 times, c is occurring how many times? C is occurring one time, and then rest of the characters, and then t is occurring one time, and then after that rest of the characters are not occurring. So this I'll create as a key here. This I'll try to create as a key inside the map, and with respect to this I'll store the first string as act here. So I'll iterate on this string, and I'll identify the frequency of all the characters. So I'll store it in a 26 size array. I'll store the frequency of all the characters in a 26 size array. Obviously I'll tell more details about it in some time. You can see here, so act will be updated here in this list with respect to this frequency here. Then after that, next time I'll be at which string? I'll be at this string, that is god. So now what will happen is, like when I'll try to update the frequency here, so what will happen is, you can see here that the frequency will be what? D's frequency is 1, O's frequency is 1, and G's frequency is 1. So you can say that A's frequency would be 0, some other characters frequency will be 0. Then after that, G's frequency will be 1. Sorry, D's frequency will be 1 first of all, and then after that some other places other frequencies will be 0, and then G's frequency will be 1, and then O's frequency will also be 1, and the remaining characters frequency that are there from A to Z, their frequency will be 0 here, all the remaining characters that have missed here. Now after that, this will be god here, so you will update god here in this list. Then after this, what you're going to do is, you're basically going to come to the next string, that is cat. Now when you come across cat, so the frequency would look something like this. A will be having the frequency as 1, B will be having frequency as 0, C will be having frequency 1, and T will be having frequency 1, and rest of the characters will have frequency 0. So it will come in this map, and then after that you'll update what? You'll update nothing but cat here. Then after this, next time I'm going to come to this string, that is og dog. Now here you can see D is having frequency 1, G is having frequency 1, and O is having frequency 1. So it will come in this particular key here, because I'm treating this frequency as a key. So this A frequency 0, rest of the characters frequency 0, D frequency 1, G frequency 1, and O frequency 1. This is where my dog will also lie. So this list will consist of dog as well. Now after that, I'll come across this string, that is stack. Now when I come across stack, so A is having frequency 1, C is having frequency 1, T is also having frequency 1. So it will come in this particular frequency consideration. So in this with respect to this map, since I'm having the frequency, so in this map list I'll create the stack string as well. I'll store this list as well. Okay, so you can see here that how I have stored it cleverly. Basically what we have done is, indirectly, if you'll try to identify, so basically with respect to the map which is having A's frequency as 1, C's frequency as 1, and T's frequency as 1, all the strings that are act, cat, and tack are stored, and the other string and all the characters have the frequency as 0. You can understand that. Now with respect to map having the frequency of D as 1, G as 1, and O as 1 as well, we have stored what? We have stored god here, and we have stored dog as well here. I hope you got my point clearly, right? So this is what we did. Now after that, like, we can simply create another list, and we can store this and this, and we can return the answer here. So this is an efficient approach of doing things, right? So the main thing is that we are trying to create a frequency array of 26 size, where we'll be storing the frequency of the characters. Now if I'm planning to create a frequency array of 26 size, will I be able to store the character A, B, C, D in that? No, actually what I'll do is, whatever characters I have, let's say if I have the character, like, I'm planning to do what in this map with respect to the frequency array, let's assume that it is a count frequency array that I have of 26 size. Okay, I'm going to update the list here. Correct, I'm going to update the list here. So if you see, since I'm planning to have the size as 26, so the index will be from where to where? The index will be from 0 till 25. So 0 will represent the frequency of the character A, 1 will represent the frequency of the character B. But how? So if you see here, if I have got the character A and I subtract A from A, I'll get 0. If I've got the character as B, if I subtract A from it, I'll get 1 here. Okay, if I've got character C, if I subtract character A from it, I'll get 2 here. Similarly, if I've got character Z and I subtract what A from it, I'll get 25. By using the subtraction of A concept, by subtracting A from all the characters, I'll be able to get their corresponding integer representation in terms of 0, 1, 2, 3 up till 25. And then suppose that a character A was there and it was occurring one time, right? If A is occurring one time, so with respect to index 0 in the count array, 1 will be there in the frequency. Okay, I hope you got my point here, how we are going to represent the alphabets in terms of integer values, 0, 1, 2, 3, 4 up till 25. So let us discuss the code here. You can see that firstly what I'll do is I'll create an answer map here. This will be the default dictionary in Python. Now after that, whenever I'm at a particular string in the array, so firstly I'll create a counter map which will be having 26 characters, and initially the frequency of all those characters would be equal to 0. Then after that, for the ith string, I'm going to do what? I'm going to iterate in the current string, and for all the characters that I'm at, I'll say that the frequency of those characters, the current character minus a, will be done, because as I said, if suppose that I have a particular character, I have to subtract it with a in order to store it in terms of its integer representation. And then whenever whatever character I'm at, I'm going to increase the frequency of that character by 1 every time. And once I have updated the frequency for a particular string, let's say my current string was what? Let's say if my current string was equal to something like ACT here, then in the count array, what will happen? In the count array, you can observe that with respect to 0, the frequency will be 1, because A is having the representation as 0. Then after that, with respect to C, who is having the frequency as who is having the representation as 2, you will store the frequency as 1. And with respect to T, there will be another integer representation and you will store the frequency as 1. So the count array will look like this, where all the other characters have the frequency as 0. So what you will do is you will store this in form of a tuple. You will store this count array in form of a tuple, and with respect to it, you will store the current string s here, and then at the end you will make a final list and you will return this answer. So I hope you got my point here. So basically the things are going to look like this only. In this map, with respect to this particular frequency array, you're going to store the list of all these strings here, and then with respect to the second frequency array, you're going to store with respect to the second frequency like this, you're going to store all these elements here. So, and at the end you will create the list of both and you will return the answer. So this is very simple, and you can see how we are doing this. So for the count array, we are creating a tuple here. Correct. This will be very easy in Python. In other languages, you have to write a little bit of implementation here. Now if you see, the time complexity will be basically order of n into k. Why it is going to be order of n into k? Because if you will observe here, so for one string we are going to iterate for k length, because we are going to iterate throughout its length and find the frequency of all the characters. So for n strings, it will take n into k time, and the space complexity will be how much? It will be n into k, because if I'm going to store one string of k length, so n strings are going to be there, so the space complexity taken will be n into k here. Now let's try and submit this code and see if it gets accepted or not. So let us try and submit this code. Hopefully it should get accepted. You can see that my code is getting accepted. I hope that you're clear with this problem. Thank you for watching this video.